We are talking about transformations of quadratic functions, and we want to be able to graph quadratic functions in standard form, determine whether a graph has a maximum value or minimum value from the value of a, graph quadratic functions in intercept form, and write the equation of a quadratic function in intercept form given the x-intercept and a point. So the first thing we're going to talk about is standard form of quadratic function, and that is ax squared plus bx plus c, where we have the a value, we have a b value, and we have the c value. We still have, the parent function is still the same for the quadratic function. Doesn't matter if we're in vertex form, standard form, or factored form. The ax squared term is the quadratic term because that's the squared part. That's what makes the graph turn into a parabola. Because our linear, if we have a linear function, that is y equals mx plus b, and the y-intercept is 0, b. And so the linear portion right here, that's the linear term. That might as well be the same thing as m. So that's the linear portion. And then c, that's the constant term. That's also the y-intercept. And the y-intercept is 0, c. Similar to the vertex form, a is the scale factor for the parabola, vertical stretch and vertical shrink. As a gets larger, the graph gets narrower and rises faster. Okay, so that's the same thing as it was for vertex form. Again, a cannot equal 0. If a is less than 0, so in other words, if a is negative, right here, if a is negative, less than 0, it's concave down, which means that it opens down. If a is greater than 0, that's positive, then a opens up. If the absolute value of a is between 0 and 1, remember it can't be 0 and it can't be 1, then the graph gets wider. So those things that we're thinking of fractions. Fractions or decimals. If the absolute value of a is equal to 1, that's just the parent function. So that's y equals x squared with some shift on it. And if the absolute value of a is greater than 1, that becomes narrow. So that's, 2, 4, anything that's greater than 1. A couple more pieces of information. So the equation of the line of symmetry, we get the equation of the line of symmetry from x equals negative b over 2a. So the equation written in standard form is y equals ax squared plus bx plus c. So we have to make sure that the big thing that we mess up is there's already a negative in the equation. So we have to make sure if this is a negative, we do negative minus 1 or negative minus b, which ends up being positive. So we take whatever the linear term is, or the coefficient in front of the x, we put it in the numerator. And we take whatever the quadratic term or the coefficient in front of the x squared, and we put it in the denominator multiplied by 2. And this will be the equation of the line of symmetry. So this will be where where the vertex lies, and also where splits the parabola in half. Now here, this is going to be our y-intercept. So we wrote that down already, but that is going to be 0, c. Whatever is on the end, that is absolutely 100% where the graph crosses the y-axis. And for the vertex is located on the line of symmetry. So x of the vertex and the line of symmetry are the same. So once we calculate this, we'll get some x value that ends up becoming our x value for our vertex. And then we can substitute that in to calculate what the y is and keep working from there.